The purpose of this example is to illustrate most of the important techniques and concepts from Part 4. We're doing that looking at a house inspector's work schedule, where there will be 2 house inspections performed in the morning and 2 in the afternoon. They will be performed all the inspections will be in either Raleigh or Cary. We're going to assume that the inspector is working from a job list that has 8 pending inspections, 3 of them being at Cary addresses and 5 of them being at Raleigh addresses. So whatever goes on the work schedule will be from these 8 addresses on the job list. The first question we're going to consider is how many possible work schedules could be made up based on this job list and this kind of work schedule. The easiest approach to that question is simply to recognize that there are 8 addresses which can be work locations. 3 in Cary and 5 in Raleigh makes a total of 8. And if you think of just making out the work schedule from the top down, you've got 8 possible locations, so that's 8 choice for which location is the first one in the morning visited. Then having made that decision, 7 choices for the second morning inspection, 6 for the first afternoon, and 5 for the second afternoon. So from the multiplication principle, that gives us 8 times 7 times 6 times 5 possible ways to make out a work schedule, 1,680. Before we leave this question, however, let's recognize that there is another approach to it. We can look at the job list and keep in mind, well, we have 8 possible addresses we could visit in the work schedule. Let's first pick which 4 places we're going to visit, and then we'll worry about how many ways to put them on the list. Since we've got 8 locations, the number of possibilities for which 4 addresses we visit would just be the number of ways you can choose 4 things from 8, combinations of 8 locations, choosing 4 of them as the ones that go on the work schedule. And then after those 4 are chosen, the number of ways to list those 4 on the work schedule would be 4 times 3 times 2 times 1, since you're really just picking the order for those 4 locations. Put it all together with the multiplication principle. This many ways to pick the 4 you're going to visit, and this many ways to place those 4 in the 4 spots on the list. Comes out to the same answer. Either of these is a correct solution, this being the simpler, of course. For the next variation of the question, we'll try to determine how many possible work schedules there would be if he wants to work in Raleigh all day. If he's going to work in Raleigh all day, that means all 4 locations inspected have to come from the 5 Raleigh addresses. So thinking just in terms of the multiplication principle, 5 times 4 times 3 times 2 choices for what goes on the work schedule, 120. Or first pick which 4 Raleigh locations you're going to visit. Those 4 locations can be picked from the total of 5 Raleigh addresses in this many ways, combinations of 5 things choosing 4, and then those 4 having been chosen can be lined up in 4 factorial ways, just like when we looked at this part up here. Another calculation giving you 120. 2 correct solutions. Again, the top one being a bit simpler. Next, let's consider how many possible work schedules there would be if he wants to work in Cary in the morning and Raleigh in the afternoon. In other words, Cary in these 2 positions on the work schedule and Raleigh in the afternoon too. The simple direct approach to that is simply to say, if the 2 morning locations are going to be at Cary, since there are 3 addresses in Cary to be visited, 3 possibilities for the first one times 2 for the second one, and then when you get to the afternoon, you're in Raleigh, 5 choices for the first afternoon spot and 4 for the second. It's 3 times 2 times 5 times 4, again, just the multiplication principle, 120. How many possible work schedules if he wants to do 2 inspections in Cary and 2 in Raleigh? No specification as to when the Cary ones and when the Raleigh ones would be. So we have to have 2 Cary addresses and 2 Raleigh addresses among the four, but they can go anywhere. Let's approach this by first picking which 2 of the 3 Cary addresses will be visited, and then picking which 2 of the 5 Raleigh addresses will be visited. So we have to pick 2 of the 3 Cary addresses, 2 of the 5 Raleigh addresses. We're counting the number of ways to pick the Cary addresses, the number of ways to pick the Raleigh addresses, and then once those have been picked, we've got the 4 addresses picked, and it's just a matter of counting the number of ways to line those 4 addresses up in the 4 spots, and that can be done 4 factorial ways. So we're again just piecing together the multiplication principle where we're using various techniques to count the things that get multiplied. Multiply all this out, you get 720 possibilities for 2 inspections in Cary and 2 in Raleigh. How many possible work schedules if he wants to do 1 inspection in Cary and 3 in Raleigh? Well, conceptually, we can do that pretty much the same way. We count how many ways to pick 1 location from Cary and how many ways to pick 3 locations from Raleigh. In Cary, we're choosing 1 of the 3 Cary addresses. In Raleigh, we're choosing 3 of the 5 Raleigh addresses. Count the number of ways to pick 1 of the 3 from Cary, 3 of the 5 from Raleigh. That would give us the 4 addresses we're going to visit, and then we have to count the number of ways to line those 4 addresses up on the work schedule, and that would be 4 factorial ways. So this gives us 720 also for the number of outcomes if we're doing number of possibilities if we're doing 1 inspection in Cary and 3 in Raleigh. How many possible work schedules if he wants to do none of the inspections in Cary and all 4 of them in Raleigh? Well, that's actually the same as what we calculated back here in this scenario, isn't it? Working in Raleigh all day long. So the solution to this question is the same as when we did that question previously. 120 ways if he does no inspections in Cary and all 4 in Raleigh. How many possible work schedules if he wants to do 3 inspections in Cary and 1 in Raleigh? So he's going to do all 3 of the Cary addresses and 1 of the 5 Raleigh addresses. To do 3 in Cary, you have to visit all 3 of the 3 addresses in Cary. And to do 1 in Raleigh means doing 1 of the 5 in Raleigh. So we count the number of ways to do 3 from the 3 in Cary and 1 from the 5 in Raleigh. That gives us the 4 locations to be visited, and then again 4 factorial ways of lining them up in the work schedule. This calculation comes out to be 120 again. Now notice at this point we've covered all the possibilities because you can't work in Cary all day because you've got 4 items on the work schedule and there are only 3 addresses in Cary. So doing 4 Cary locations and no Raleigh locations is not a possibility. We've treated all the possibilities. So let's do a final check of the consistency of the answers we've obtained. To start with, we counted a total of 1,680 possible work schedules altogether. And it's either going to require 2 inspections in Cary, 2 in Raleigh, 1 and 3, none and 4, or 3 and 1. There simply aren't any other possibilities than these. So if we've counted each of these subsets correctly, we should be able to add these up and get the total, because these all together cover all the cases. And you can check that. 720 plus 720 is 1440. Another 120 is 1560, and the final one 1680. So here we add because we have simply split the total possible work schedules up into batches. And if we've counted each batch correctly, then the sum of all the batches, the sum of the number of elements in all the batches should add up to the total number of possible work schedules, which it does.